Hello everyone. In the previous video, we learned what machine learning algorithms are. That is to say, what is its definition. So in this video section, we will learn about the classification of machine learning. This photo illustrates the 4 classifications of machine learning: supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. Supervised learning is also known as supervised learning. Its definition is to use samples of known categories, train, and learn to obtain an optimal model. In other words, all samples in it belong to the same category. So, in this place, please pay attention to this known category. What do we usually call this known category, referred to as tags? In other words, when we get the sample, or when we get the data set, its tags are consistent. In other words, we have obtained a piece of data. What label does this data belong to, or what its true value is, we know this. So we use this type of data, completed the construction of this model, completed this machine learning algorithm. It belongs to supervised learning, or supervised learning. Then the second category, it is unsupervised learning. Corresponding to the just mentioned supervised learning, unsupervised learning is very easy to understand. It is this type of sample that is unlabeled. In other words, this place has no labels, no label. Simply utilizing the characteristics of the data itself, birds of a feather flock together. It simply utilizes the features of the data itself. Complete the construction of the entire model, or completing the process of tuning the learning parameters of this model. Then it belongs to unsupervised learning. Next, we have semi-supervised learning. With an understanding of supervised learning and unsupervised learning, I believe most of you can probably guess the definition of semi-supervised learning. This is its definition. It enables the learner to automatically utilize a large amount of unmarked data, so learning with a small amount of annotated data as assistance. In other words, I used another small portion of labeled data, but at the same time, there is a large amount of untagged data you should also make use of. In the case of using both types of data, then you are using a semi-supervised learning. So the last type of classification is reinforcement learning. Learning system is the mapping of behavior from environment. This is very important. It is learning by mapping. It is different from the labels used in previous supervised learning. It is the system and environment. You can think of the system as your model. But this environment and the labels we just talked about, let me check here. This is not equivalent. The inequality here is not equivalent to the tags. The place hopes everyone can just pay attention. So, the reward signal or reinforcement signal, reward signal, strengthening signal. This is very important in reinforcement learning. Its function value is the largest. Reinforcement learning is different from the supervised learning we just talked about earlier. Mainly manifested in this teacher's signal. It's the signal from the environment we just talked about regarding the teacher. I just explained their definition to everyone. Next, we will explain each category in detail, the key point among them. Then, if they use a small example from daily life to understand, come on, we can look here. This is supervised learning, data features, feature 1, feature 2, feature 3, all the way to feature N. Then the corresponding part behind the supervised learning algorithm is the label. This is what we just talked about. This is the most critical place. It's just a label, supervised learning, or in other words, all data sets for supervised learning must have labels. Attention, everyone, this is a data. This is another piece of data. If the model we are working on now is to distinguish between men and women, so here is a person 1, this is person 2. So the characteristics, for example, the first feature might be a beard. The first beard, then there are also many features in the middle, for example, legs or face, and a series of features, whether it's person 1 or person 2. He will have all these features. He may have a beard if he is a man, has legs, face as well. But women, probably just beardless, but there are legs and a face. In other words, each piece of data, he will have many features. So, the most crucial part of supervised learning lies in the labels. I need to tell him that this is a male, this is a female. After telling him this way, he is able to complete the entire process of learning this. Algorithm. Sometimes some students may ask, so I know now that he is both male and female. Then what else should I study? Just because you know about male and female, you need to study the characteristics of men and find out what kind of patterns they follow. Among women, what kind of pattern do their characteristics follow? When these conditions are met, when a brand new data, when you want to make predictions, a brand new piece of data has arrived, he only has these features on the left side. When there is no tag on the right side, your model or your algorithm can provide a predicted value or provide a predicted label. This is supervised learning. For example, let's take the example below. Do you enjoy sports? He provided these features: weather temperature and wind speed. Do you enjoy sports? When the weather is good, when the temperature is warm, the wind speed may be a bit strong at times. We all enjoy sports, so if it rains, the temperature has dropped, although the wind has weakened a bit, but we don't enjoy sports. So, we are based on these labels of enjoying or not enjoying sports. When we find out what distribution our features present, we may enjoy sports. What kind of distribution might we present? We don't enjoy exercise. This is an effect achieved by supervised learning. We need to first inform him of what conditions need to be met. What will we do? Then this model knows, okay, what conditions will you meet in the future? What kind of things are we going to do? This is supervised learning. What problems can supervised learning typically solve? For example, this is a regression problem. Return to the problem. It reflects the characteristics of the attribute values in the sample dataset. Mapping the sample relationship through function expressions, discover the dependency relationship of attribute values. So, returning to the question, that was his definition. Just remember one thing. What is the biggest characteristic of the regression problem? Usually, the issue of regression is all about you and a trend. For example, here, you may have a large number of sample points. However, the key point is to return to the issue. It is to fit a trend between your sample points. For example, how much profit can this stock bring me next week? What will be the temperature on Tuesday in Celsius degrees? You may be in a period transitioning from spring to summer right now. Your temperature will gradually rise. Then you might want to fit it. What will the temperature be like next Tuesday? His focus is to fit such a trend. Your model is fitting such a trend. After fitting such a trend, you will know at the next time point or at the next location you want to predict. What kind of prediction value can you get? What kind of result did you get? Supervised learning will also solve a type of problem, which is classification problem. I believe everyone is quite familiar with classification problems, all very simple. So he actually just takes A, B separate like this. For example, the type mentioned in the example we just gave, will there be traffic congestion on the road during tomorrow's morning rush hour? There will only be two outcomes, may or may not, so which means are more appealing to customers, 5 yuan or a 25% discount. It's about making you choose either A or B. It means either A or B as indicated on our graph. So, is this simpler for supervised learning? Because of his tag, I only need to label A and label B. In life, there are also a large number of these classification problems. Select the one that belongs to A. It is better to choose that he belongs to B. Next, let's take a look at unsupervised learning. Unsupervised learning is also very common. If everyone pays attention to the film just now, one of the most commonly used algorithms in unsupervised learning is called clustering. Clustering algorithm is the most typical algorithm of unsupervised learning. Among the common algorithms in machine learning that we commonly use, we'll introduce everyone to this clustering area. First of all, everyone can see that the data on the left is still related to supervised learning, or there is no difference from supervised learning. But does the right part lack labels? There are no more labels here. It only has one internal similarity here. There is only one intrinsic similarity here. What is unsupervised learning? Unsupervised learning is when I give you a large number of data points all at once. Each data has a lot of features, but you don't know how these data should be classified. Let's make a hypothesis. It's an example like the one below. In the following example, from this example, it can be seen I only know about the monthly expenses. So many products. Spent so much time on this. They may be some people may spend this amount of money every month. What to buy? Then the consumption occurred in the morning, around this time in the morning. So there are some people will spend 500 to 1,000 yen to buy a basketball and then spend time in the evening. So I want to know about these people. They can all be divided into several categories. What kind of characteristics do they all have? I believe that at this point some students may have some ideas. Maybe now our JD or Taobao. He categorized us into so many groups backstage. He can create a user profile. Here, user profile. Many times, user profiles are created using unsupervised algorithms. For example, people in the first two categories, he bought badminton rackets and basketballs. I classify him into the first category. He may belong to a type of person who loves sports, although their consumption time and monthly consumption amount are different, but we may all categorize him as someone who loves sports. Because there is a very close connection between their products, all purchased items are sports-related products. This game console is obviously different from their category. Is it possible for clustering to cluster into something else? For example, 1 and 3, I classify them for him. Their consumption level may be relatively high. The consumption level is relatively high, while the consumption level of this person in the middle is relatively low. Is it possible to have other clustering methods? It's all possible. This is also a value of unsupervised learning. Why do you say so? Sometimes we clearly know how many categories our data should be divided into, but most of the time we do not know how to categorize our data, or we haven't fully discovered the inherent value of our data. At this point, unsupervised learning can help us discover the intrinsic value of our data. Now let's take a look. This is what we just mentioned, the most common problem solved by unsupervised learning, or some of the algorithms he uses most often. It's clustering. He goes through all the samples in the dataset, the compatibility of their own characteristics, cluster this dataset into several categories. The most common algorithm is called k-means. Later, we will also talk about this algorithm k-means. So, through these examples, let's try to understand which audience likes to watch movies of the same genre. I believe the simplest example is girls may prefer this kind of youth romance movies. I prefer romantic movies. Boys may be interested in science fiction. Action movies tend to be more popular. But if you didn't know at the beginning, how should these be distinguished? You only know such a group of people who like youth movies. Those people like action movies. Then you will naturally divide these two types of people into two categories. So there is another example. What are the similar ways in which these parts are damaged? Then you usually also look at their damaged positions. Due to their internal damaged location attribute, they have similarities, so you will classify them as a group, just like the way shown in this image on our right side. So in unsupervised learning, one thing everyone must remember is, unsupervised learning is a classification based on the intrinsic similarity of data. Next, let's take a look at semi-supervised learning. With the previous supervised learning and unsupervised learning, there is now a learning. I believe everyone will soon grasp the essentials of semi-supervised learning. Let's take a look at the right side. This is the biggest feature of semi-supervised learning. Some have labels, some are untagged. This is how the data of semi-supervised learning looks like. So, in the context of the example we just discussed, just like this, some have labels. However, some data is untagged. How to complete the semi-supervised learning algorithm. We have labeled supervised learning. We can directly label it. Then we establish our model, unsupervised learning algorithm. We utilize the connections between these features. Clustering. Complete our algorithm. What is semi-supervised learning like? Semi-supervised learning can actually do a lot of things. For example, return, for example, classification. It can even perform clustering algorithms. Clustering algorithm. Okay, so here, let me explain this with an example. For example, we use semi-supervised learning. It goes to do a classification. So we definitely start with labeled data, train a model, then we feed unlabeled data into the model again. Take a look, provide a pseudo-classification effect. Then we will select these, good data. Let's continue to optimize our data and further optimize the model we ultimately want to achieve. In this way, it's a process of semi-supervised learning. It's using these unlabeled data. Go to assist us with a labeled piece of data. So this is for a classification task. When we are doing other tasks, there will also be labeled data to assist us with this untagged data. For example, when you are doing semi-supervised k-means clustering, you can start with the centroid point. Choose to be on the centroid of labeled data. Okay, so this is one of the main ideas of semi-supervised learning. So the next one, it is also the last type of machine learning algorithm classification. Reinforcement learning, not very common, but it is also a very crucial step for future development. The overall model of reinforcement learning looks like this. It is between the model and the environment. In this part of the model, everyone can understand it as an algorithm. What is the environment? The environment can be said to be the teacher we just mentioned. Wasn't there a teacher signal just now? What is the working mechanism of reinforcement learning? Definition is the model's perception of the environment. Take action, adjust and select based on status and lecture schedule. In other words, it's like a teacher teaching a student. The student may first take an action to give to this teacher. Then the teacher makes a judgment. Incorrect. You did it wrong, so I won't tell you what you did wrong either. The teacher just tells you directly that you are doing it wrong. Return back again. This is the reward and status. The status is simply doing it wrong. What is reward and punishment? If the foundation is not done correctly, you figure out how to make the changes yourself. Sometimes our former class teacher may be like this. Think about where you went wrong. At this moment, our algorithm will take a second action again. You want me to change, don't you? I think I must have done this wrong. At this point, the second teacher will provide feedback again. At this time, this feedback may be, you did a good job. It's also possible you're not doing well. No matter which type of feedback, this algorithm, or rather this student, will remember it. You have given me feedback again compared to the previous feedback. Are you saying I messed up again, or should I say I did better? If I do better, I'll just go in this direction. I will continue to make changes. If you say I did worse, then I'll go in the opposite direction. I'll go change it again. So this is the overall working mechanism of reinforcement learning algorithms. In reinforcement learning, a very crucial issue is the problem of optimal behavior. The goal of reinforcement learning, like we have the goal of supervised learning, just find the tag that corresponds to the category he should belong to, and that's okay. So reinforcement learning is about finding the best action. What is the best behavior? Let's recall AlphaGo, Deep Blue, autonomous driving. Do you all have some ideas? In our example, we also mentioned our self-driving car. When the yellow light starts flashing, should I brake or accelerate through? This is a test of the best behavior. AlphaGo as well. He was able to defeat Lee Sedol of South Korea. Later, he defeated RKG. He is considering my next moves in this game. Which move is the best behavior? It is a process as a whole. Instead of just completing a classification task or a regression task as we did before, he is a process of seeking the best behavior as a whole. Another example is for a vacuum cleaner robot. Is he going to continue vacuuming or go back to recharge? He needs to consider his current battery level, the terrain he is facing, he has completed the task, etc. In other words, reinforcement learning is more like a student learning. After the students have completed their studies, his ability lies in being able to do his current job better. In other words, for our algorithm, the model and algorithm of reinforcement learning, his purpose is to better accomplish our learning tasks, find the best behavior to complete this learning task. Okay, in this video, we will stop here. The focus of this section's video is to explain the 4 types of classification algorithms in machine learning: supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. In the next section of the video, we will provide an overview of the overall process of machine learning for everyone. Goodbye.